Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday Musings. The Silurian period saw many changes. One major change was the stabilization of the global climate after the Endordovian glacial event. Or so we thought. Recent studies of carbon and oxygen isotopes have actually brought to light a rather volatile ocean atmosphere system, which correlates to some of the minor extinctions of the time. Overall, there was an upward trend in warming globally, which makes sense when you're coming back from a glacial event. Sea level was about 200 meters or 656.2 feet higher than today. However, there were some abrupt biodiversity changes noted with nothing to really explain them. Leonard Jepson had discovered a cyclic stratigraphic pattern in the temporal distribution of conodonts preserved in the carbonate platform rocks of Gotland. The cyclic pattern, which was also paralleled by cyclicity of lithologies, was explained through an oceanic model that described shifts between two stable ocean climatic states. The driving force for the cyclic pattern was changing areas for production of oceanic deep water over time from high latitudes to low latitudes. These cyclic changes have been linked to three significant events: the Irrviken event, the Mold event, and the Lau event. Each of these are minor extinction events. The Irrviken of the early Silurian was a profound extinction of conodonts. The survival ratio was 12 out of 60 globally known species, and they never recovered. Graptolites were also hit pretty hard. Chitinozoans and acritarchs experienced a turnover, meaning that some went extinct while others appeared in the fossil record. So they changed. And this event appears to start after a sea level fall or regression. In the middle Silurian was the Mold event. Graptolites suffered the most this time. In fact, the accumulation in some areas literally blackened the bedding plains. Contemporaneous formation of organic rich shale, alum shale, and not least the formation of the so-called boundary coal seam in deepwater environments shows that anoxia was widespread. Other pelagic groups were hit as well, including planktonic radiolarians. They went from 28 species to 2. Again, this event started, at least, with a regression of sea level. In the late Silurian was the Lau event. The poor conodonts were hit again, losing 17 of the 23 species they had by the end. Graptolites were reduced by 70%, and brachiopods and bivalves experienced a large turnover. Again, this is associated with a substantial sea level drop. Are we sensing a pattern yet? Overall, while there weren't significant changes in global climate, there were significant changes to the sea level, which may have been some minor glaciations, which would trap water, which was causing the environments in the ocean to change. If the area you're living in suddenly isn't covered in water, you're not going to be a very happy marine animal, are you? So while there weren't any major extinctions, no global destruction of everything out there, those that were not able to get back into the water fast enough suffered a lot. Well, thanks for coming to today's lesson. If you're interested in reading more, you can check out the paper that I had looked at for this. I'll leave the link in the description. And tune in tomorrow to participate in some fun trivia. Fossilize you later.